Have you ever wondered what are the different possibilities of applying design automation in a design team? Here I am referring to use of NXOpen customization and programming in a design team as a productive tool that uses the digitalization to its fullest to benefit the time and quality in work. So here in this video, I am going to talk about what are the different types of design automation possible using NXOpen customization and programming. So let's get started. Here you see that I have populated the top 5 different types of design automation possible using NXOpen programming. So we are going to start the first type of automation, which is very popular as well, called product configuration. Why it is popular? Because it has a capability to save lot of time for the design engineers, and also it can ensure the utmost quality in the deliverables, for example models and drawings. And it takes out lot of routine and mundane work from the design engineers. So let's see what exactly is product configuration. Here I have picked up one example. This example is of conveyor belt. You can imagine a conveyor belt which looks like something like this. So this is a conveyor belt, and there could be several components and several parameters that require to create the design variant of this conveyor belt. So let's see what could be the design parameters required to configure this conveyor belt. First of all, the important parameter is whether it is a roller belt or a flat belt or a modular kind of belt. There are few more different variety of belts available, but I just wanted to simplify the things for you. So this can be the important configuration parameter. The other parameter could be belt motor capacity. Based on how much weight that conveyor will carry, what is the number of items that total number of items that belt will carry at a time. Based on that, the belt capacity, motor capacity will be defined. And again, there is a pulley which plays an important role to move this belt. So what is the type of pulley and what is the direction of that pulley is an important design parameter. Then of course the belt material, which depends on which kind of material this belt is carrying, whether it is an anti-skid material or not, and based on the type of material it is carrying, type of item that it is carrying, it can be either plastic belt or rubber belt or something else. Again, the important size parameters of a conveyor belt are width, height and length. Of course, if it is at an angle, it is at inclination, then the inclination angle is also important. And at the end, the bearings that can be used for making this conveyor belt. So now you can imagine, as a design engineer, when you are working in a design of a product, something like this, then you take care of all these different things together and you create one configuration of a conveyor belt design that suits the inputs related to these parameters. Now what this product configuration tool do is it captures all these parameters, and then there is a design automation program written which takes these parameters all together, works on a logic, calculates the logic parameters, and those logic parameters ultimately end up in creating the new version of model into your NXCAD software. Not just model, but also drawings. So imagine that you are, as a design engineer, giving the inputs in a dialog box for this conveyor belt, and at the end, after processing of the models and the entire logic, you get the set of models including the drawings in, let's say, 15-20 minutes. So this is a possibility, and this is very well possible with the product configuration type of design automation solution. And I have done it lot of times. Even maybe in my future videos I will look to include some of the examples that can give you more clarity how it is possible in the real world. This is one potential and popular type of design automation. The next is batch process. When we wanted to perform any activity, small or big, that too on huge number of files. In this case, it can be a part file, assembly file, or a drawing file that you wanted to work on. But you wanted to perform some activity, some task on hundreds or thousands of files. Then that time it is called a batch process. The example of this could be, you would like to convert all the files from one version to another. It is one CAD version in which those files are available, and you would like to convert that into the other version. So that time this batch process kind of application is developed. Then other example could be creation of DXF or PDF files for all the drawings. Then it could be adding metadata properties. These metadata properties, in addition to the existing properties that could be there into your model files, it could be the properties related to mass properties. It could be related to the bought out or procured materials. It could be the product family, product group that it belongs to. It could be the part number, or it could be anything which is very specific to your way of working in an organization. But if it is something that you are doing in a bulk for all those hundreds and thousands of parts, then it is called a batch process. Though the kind of task you are doing is very small, but as an impact wise, it is something that you are doing on the lot more different number. It is either in thousands or hundred. That time, because of this number, it makes a huge sense, and it can save a maximum. It can save a maximum time for you, maximum potential time for you. The next type of design automation is exporting some information. Either it could be converting the files into step file, IGS file, or a XT file. It could be converting the drawings into DXF, DWG, or a PDF file. Or even it could be extracting some meaningful information in an Excel file or a similar, which can be further used by either a manufacturing team or a procurement team or a planning team or whatever. So it can be any information that can be processed further by other departments, other teams. This information can be including the mass properties. It can be the weight of the different steel items, including plates that you have on your model. And it could be the weld information. You would like to count, you would like to measure the total weld length required to assemble that structure. That could be one of the information that you can extract. It could be the paint area that you would like to measure, because based on that area you might be looking to order the paint required to paint that entire structure. So it could be any information which is very specific that can be exported even in an Excel file like this. So it is another kind of automation that is again popularly being used, being developed in across any industry type. The other one, which I would say falls under little advanced type of development, because here you don't just need the the knowledge of NXOpen programming and customization, but you also need the knowledge of other software tool with which you are integrating your solution. It could be broadly classified into two categories. One is integration with a PDM or PLM tool, or else integration with CAM or CAE tool. It can be the NX CAM, or it can be other CAM or CAE tool that you are referring to, but it can be any software that with you are actually trying to integrate the model information, so that the models can be seamlessly transferred to the other software, and then you don't need to do manually anything in that process. So this is related to the integration. Now the last but not the least, which is end-to-end automation. This again involves having the skill set of other software developments as well, because when we try to develop something which is end-to-end automation, it is not just limited to NXOpen programming and customization. It can be way much beyond that. Let's have one conceptual example of the same. Maybe we will take the same example of conveyor belt here. So it can be converted into the end-to-end application, which is not just limited to the NX software where you are adding the parameters and getting the output as a PDF and not PDF but drawing end models, but it can start much before that. For example, it can start from the conceptual design stage at all. Maybe in this case, you will have one portal which is either a web-based portal or some other kind of tool that you have developed to have that portal. In that, all the inputs you fill in as a tender engineer or a concept engineer who enters all the parameters based on the client requirements, and that you do for the sake of calculating the cost and efforts required to develop that client specific design. And once you enter that all the parameters, here the automation will not generate the models and drawings. Maybe it will generate a conceptual model, but it will mainly focus on calculating the cost and as well as the efforts required to develop that design. And once that inputs and cost and efforts results are ready, then it can be reviewed by someone who can validate these inputs and also cross check that against the client requirement, so that the design team can get the go ahead to start working on the detailing of the design. Then once the validation is finished, then what you see in this step number 3 is exactly what we have seen in the product configuration. So here in the detailed design, all the detailed parameters are key in, and then what we get as outcome is the models and drawings. Of course, once we got the models and drawings, we cannot rule out the the validation process. The validation is still required, and then the other set of engineers who are good at product understanding, they perform the checking and approving of these models and drawings together. And what happens at the end, these drawings, this entire documentation of a design is released and handed over for manufacturing, or even after manufacturing, it is handed over to the client along with the physical delivery. So this can be the end-to-end automation. It can also involve use of the alerts, notification. It may be the email notifications, those are triggered. It can also involve the approval process through email or such PLM or PDM tool. But it is not just limited to the design, to the CAD automation or NX automation. It can also use the other tools as well, in short. Okay. So this is the other type of end-to-end automation. Again, end-to-end automation is something that takes a lot of time to develop, because it is not just limited to the NX. So it is much beyond the purview of NX automation. So these are the different 5 types of automations, as per me, are very popularly used, and any major or minor automation can be categorized into these 5 major types of automation.
If you like this video, then definitely please uh, hit that like button. And if you wanted to receive such video updates from me, then please do subscribe to my channel as well. Thank you for now. See you. Bye bye.